Right. So if anyone doesn't have much to talk about, I think I do have something interesting. I don't have a proper presentation lined up, but how many people have here are working with Kubernetes or have worked with Kubernetes before? Others? I see Aditya. Never? Okay. I mean, everyone has heard of Kubernetes, right? And why it's useful. It's mainly for containers. It allows you to schedule and orchestrate your containers across multiple machines. It makes it easier to create networking across these containers and all that. So Kubernetes does a lot of things for you. But one major part which I've been focusing on was Kubernetes networking itself. I did wanted to read more on CNIs itself. So I'll start sharing my screen. One of the things which actually caught my eye, sorry, this is not what I wanted to show. Yeah, okay. So one of the things which actually caught my eye was Cilium. So Cilium is one of these open source softwares which we don't really talk about, which we don't really work with on a day-to-day basis. It's one of the other competing projects like Calico. So both Cilium and Calico are basically CNIs for Kubernetes. They both happen to use something called eBPF. So eBPF stands for Extended Berkeley Packet Filter. So the idea with both Calico and Cilium is that you can completely get rid of IP tables. If you have worked with Kubernetes, you would know that IP tables are kind of like the de facto mode in which Kubernetes works, especially when you have communication across containers which are deployed across nodes. So if two containers which are in two different nodes communicate with each other, they need to sort of use IP tables, and they have to do DNAT as well as connection tracking in order to ensure that the packets from one container can flow to the other. eBPF is sort of a technology which allows you to deploy these Linux-based programs, these small subset of C programs, which can work directly within the Linux kernel itself. So you can kind of write these programs in C, which can relate itself to network packet filtering and all that. It can relate to, let's say, like whenever any incoming packet comes in, these eBPF programs can get triggered, or any packet which is leaving your network, which is leaving your node is getting triggered, will trigger this eBPF program. So based on the IP addresses which are there in the packet itself, or based on the ports which are there in the packets, it can actually do a lot of things for you. Like, for example, it can filter the packets. It can also like whether allow, deny, or forward that packets. It can rewrite the packet headers as well. It can send the packets to that original destination as well as to some other system which can monitor that packet as well. So eBPF programs are super powerful. You can definitely do that even at a higher level. But the advantage with eBPF programs is these programs actually run in the kernel space itself. They don't run at the user space level at all. It's a revolutionary technology. How many of you have used Wireshark before? Wireshark or TCP dump before? Anyone?
Yes.
So I think with yeah, a few people have. Okay. So the thing with Wireshark and TCP dump is that they allow you to sniff packets when in flight. Like, for example, let me open up Wireshark on my machine. I think I have Wireshark already installed. So Wireshark basically looks at all of the packets which are flowing through your machine. Wireshark actually uses something called BPF, which is Berkeley Packet Filter, which is a 1990s technology. It's almost 20, 30 years old technology. And it allows you to visualize and to see the kind of packets which are flowing through your system itself. Like, for example, I can see that, hey, from the source IP, which is probably my own local IP address. So from my machine, there's a UDP packet on port, to port 8801 to the destination 134224 and this particular destination IP address. So I can get a lot of information through Wireshark. So Wireshark also tends to use the same BPF filters in order to just monitor your packets itself. But with eBPF, you can add, or you can actually configure or write your own sort of filtering or monitoring logic for your packets itself. So, so there's Cilium and Calico, which actually are built on top of eBPF, which allow you to do all that particular filtering itself. So Kubernetes has a particular resource called network policy. How many of you have used network policy before? Of the subset of people who used Kubernetes? Anyone using network policy in their production applications? Let me do one thing. Let me actually bring up a Kubernetes cluster. I'll just show you a quick demonstration. I'm going to use Kind. So Kind basically allows me to create a multi-node Linux cluster locally. Sorry, I don't have Docker running. Let me first start Docker. Give me just a moment. So Kind is basically an open source software which allows me to emulate multiple nodes. So Kubernetes is something which works across multiple machines. I don't have multiple machines handy right now. I don't have a Kubernetes cluster handy right now. So it allows me to create a sort of a simulated Kubernetes environment itself. So I can use Kind, once Docker is up and running, I can use Kind to create cluster or to simulate a Kubernetes cluster using my single machine itself. So it sort of uses Docker machine under the hood, but that's not relevant. It also has its own CNI as well. Let me actually cd into Cilium. So I'm going to create a Kubernetes cluster with Cilium installed. So Cilium is a CNI. So CNI is basically the one which is responsible for networking across nodes itself. Kubernetes has its own, I think, kubelet. No, sorry. I forget the default CNI which Kubernetes uses, but that one actually relies on IP tables itself. Cilium also by default relies on IP tables, but you can actually configure it to not use IP tables as well. So I'm just creating a Kind cluster with Cilium installed. I do have this particular makefile. Give me one moment. Let me show you my makefile as well. So I have a Kind cluster created without any CNI by default. So I'll show you this particular configuration. Seriously. Okay, DevOps config, Kind, multi-node.yaml. So this one disables the default CNI. It's just going to create a Kubernetes cluster without any container networking interface by default. So CNI stands for container networking interface. And once that cluster is up, let me show you one particular thing which I can do with it. . So here I have kubectl get pods and kubectl get nodes by default. So let me show you the nodes by default. So it says that the status is not ready. That's because I don't have a CNI. All of the nodes cannot communicate with each other at all. So now let me actually install a CNI plugin. So I'm going to use Cilium itself. So Cilium has a few options. I've already installed the Cilium CLI, and I can use Cilium itself to install Kubernetes on, or Cilium CNI on Kubernetes cluster itself. So using this, I can then create network policies. So network policies are basically a Kubernetes resource which doesn't work if you use just the default CNI. So you need a CNI plugin which can actually enforce this network policies. And network policies basically allow you to dictate which container can communicate with which kind of a container itself. Like for example, here I'm selecting a DB pod and I'm saying I'm only going to allow incoming requests from these particular IP addresses or these namespaces or these pods on this particular port. So network policies, they tend to allow you to create these security policies or to control the communication which you have within your Kubernetes cluster itself. So once Cilium is installed, I can give you a very short demo of it. But this is something which actually is what eBPF is doing. So Cilium actually uses eBPF under the hood. It deploys this kernel programs, these eBPF programs, which actually filter these packets. So if there's a request which does not originate from, which does not match any of these particular things, it will just discard that particular project, or sorry, drop that particular packet. So let me see if it runs. So it's just trying to install Cilium. Kind created that cluster, and now Cilium is being installed on top of that cluster. Give me one moment. Let me just run some diagnostics on it. So I'm going to use kubectl itself, and I'm going to select the pods from kubesystem. So Cilium actually installs a few pods on my Kubernetes cluster. So it's actually installing some Cilium agents for each node which I have. I have 3 node cluster. Shouldn't matter which particular node I'm running this on. This particular command on, I'm sorry, it doesn't matter which namespace I run kubectl get nodes on. I can see all the nodes. I have a 4 node cluster with one of the nodes as the control plane and the other nodes as the worker plane from joining the worker plane itself. So once this is up, so it seems my control plane is ready. That's because Cilium is installed. So once Cilium is installed, I get IP addresses assigned to each each node in my cluster, as well as I get IP addresses assigned to each pod in my cluster as well. So all of the pods have their own internal IP addresses. So some of the pods are having IP addresses in this subnet, in 10.244 subnet, and the others are sharing the node subnet itself. So Cilium is installed. I can also look at Cilium status to actually check the status of Cilium itself, the Cilium installation itself. So it tells me that Cilium is installed, and now I can actually deploy a few different things onto my cluster itself. So let me start by deploying a particular project, which is Hello K8s. So Hello K8s is going to deploy a single pod, which is Hello Kubernetes. with a service in front of it. So this particular pod does have just one HTTP server, which can tell me which particular node it's running on. So I'm just going to deploy this particular just going to apply this particular YAML and deploy this particular pod onto my cluster itself. So I get my pods running and I can check the containers starting on it. So the containers are starting. Once the containers are running, I can actually deploy these network policies to control how the containers communicate with each other. One of the other things which I'm going to also install along with my hello is my curl pod. So curl is basically just a Ubuntu pod, and it has curl installed on it, pre-installed on it, so that I can actually run a few different commands from within the cluster itself. So I'm going to deploy this particular pod as well. Kubectl apply should apply this pod. So once these two pods are created, so I have curl pod as well as my hello Kubernetes running as well. So here, what I can do is I can sort of also check which node my pod is deployed on. So if you see, my curl pod is deployed on kind worker 3, whereas my hello pod is deployed on kind worker node 2, 3, and 1, because there are 3 instances of it running. So now I'm going to do one thing, which is to execute a bash inside my curl pod. So I would have to provide the option -it. And one thing which I'm going to do is I'm going to start by hitting this particular IP address. In Kubernetes, by default, any pod can reach any address itself. Give me 1 second. Let me just confirm the pod IP address. Not the pod IP address, but the port number. So I have my container port at expose on port 8080. So I'm going to try and make a curl request from my curl to a pod which is in some other IP, which is running on some other node, and I can still network them. That's because Kubernetes sort of creates these bridge network across these containers and allows the nodes to talk with each other, allows communication across containers to talk with each other. So that's the default mode. So network policies actually allow me to control this particular conversation itself. So here I'm going to deploy one particular network policy. Let me cd into 04 network policy, and I'm going to deploy this particular network policy, which is to deny all ingress.yaml. So the idea with deny all ingress is I'm going to select all pods in the given namespace, which is the current namespace, and I'm not going to allow any incoming request from anywhere. So I'm leaving the ingress empty. So let me deploy this particular network policy. And now let me make the same request again. So now when I make the same request, I can't communicate across these two pods at all. That is, my curl pod cannot make a request to my hello Kubernetes pod anymore. So something like this, these network policies are actually implemented using eBPF programs under the hood. So both Calico and Cilium are CNI plugins which use eBPF. Any questions at this point? I think this is the only thing which I have to show right now. I did want to prepare a talk more involved. I did want to talk about Cilium more because Cilium is actually written in Go. So Cilium has this really cool plugin. Sorry, I forget the name. One second. Let me go to GitHub of Cilium itself. So Cilium has this project called Link, I think. Yeah, eBPF itself. So they have this entire library written in Go, which allows you to deploy and write your eBPF programs. So eBPF programs are definitely much more complicated than writing Go programs itself. Usually in a lot of deployments, you don't tend to write a lot of eBPF programs yourself. There are a lot of different companies which are coming up, which are using eBPF a lot more. Like, for example, just this morning, I think I saw another company called, give me just a second. I forget the company name. Just looking at my notifications. Matheson, yeah, ContainIQ. So ContainIQ is a Kubernetes native monitoring that also coincidentally uses eBPF. It basically uses eBPF programs to sort of monitor, to deploy these C programs onto your Linux kernel itself, onto the Linux kernel of your node itself, which can monitor the metrics and events within your Kubernetes cluster itself. So it's the same technology which Cilium is using to provide to block connections across containers, and the same technology is being used by ContainIQ itself for monitoring. Cilium also has a monitoring component built in, which is called Hubble. I've not talked about Hubble. I'll not talk about Hubble right now, but I do want to explore this more in a more polished talk. But I just wanted to give you a overview of eBPF itself. So would that be something which you'll be looking forward to in any of the upcoming meetups?
For sure, Gaurav. Yeah, that was really great. I mean, one question though. So I have, we have Istio set up in my, in the cluster in my workplace. Mm-hmm. Will eBPF will have any clash with Istio? Because generally in Istio, what we do is the service to service level communication is actually, if you want to limit that particular service, is allowed to talk to another service, we do it with the Istio manifest. So will this have any, because Istio also underlyingly it actually uses IP tables. So, so just a question on that.
Sure. Let me try and visualize this actually. Your question is very valid because a lot of, even for me, when I was being introduced to CNI, I wasn't really sure how CNI and service meshes relate to each other. But the way you can think about it, the easier way to think about Istio versus CNI is, let me first draw a few nodes. So here I have my Kubernetes nodes. And what I'm going to do is I'm going to create or show you a few pods within it. The thing with Istio is, Istio doesn't work on its own. It has its control plane component and the data plane component. Istio's data plane component is nothing but envoy. It's basically a tiny little proxy which runs along with your pod itself. So here, let's say you have your application pod in yellow, you'll have a envoy proxy running within each of your pods in your Kubernetes nodes itself. So this particular pod is the one which is responsible. So it basically acts as like your gateway, and it ensures any communication between pods is controlled using this particular proxy itself. Does that make sense?
Yeah, got it. Gaurav, yeah, go on. I think, yeah, basically Envoy basically manipulates IP tables, right, to proxy those IPs to the...
Envoy doesn't manipulate the IP tables.
Oh.
In fact. So in fact, it's just a proxy which sits inside your pod. At least that's what I understand. So your Envoy containers, sorry, I've been calling them pods. So these containers sit within your Kubernetes pods.
Yeah.
Along with your application itself.
Correct.
So your application would also have, you have your application containers as well, which will be deployed inside your pods itself. So you don't actually configure these Envoy containers to run within your pods, but rather your Istio controller is responsible for injecting these Envoy proxies within each of your pods.
Okay.
Now, with eBPF, with CNIs, you don't have to have this proxy at all. So there is one inefficiency which you can already see. For each pod which I have in my cluster, I would have to have another service, another Envoy container running along with each pod. So the resource usage actually goes up. On the other hand, if you have something like CNI, something like Cilium, Cilium basically has this eBPF programs which run at each Kubernetes node level. So these eBPF programs, they have something called eBPF maps, which have kind of the logic. They have kind of the, what do you say, the filter rules. And these eBPF programs would have any outgoing packet. Let's say from this particular container 4, I want to connect to this container 1. So my packet will flow through the H0, that is the Ethernet interface of that particular node itself. And from that node, that particular packet will float to the H0 of the other node itself. And once it hits this particular H0 node, it's going to ask the question, is this particular source IP allowed to perform this particular operation or is this particular destination IP allowed to perform this particular operation or not? So you basically have these layer 2, layer 3, layer 7 proxies or filtering, which is possible with eBPF programs natively. So it leads to more efficient resource usage. Does that make sense?
Yeah, got it. Right. So maybe another. Yeah, go on.
Yeah, go ahead. One other thing with Istio and with Cilium is, with Cilium and Envoy is, Cilium also does use Envoy. Sometimes you might want to implement something like a MTLS. So MTLS stands for mutual TLS. That is both your sender and receiver needs to have SSH communication SSL communication where both the client and server are authenticated against each other. So Istio does allow you to do that. You can do the same thing with Cilium itself directly. That is, Cilium itself can, apart from running your eBPF programs or managing your eBPF programs, it can also deploy these Envoy proxies or inject these Envoy proxies along within your pods in order to enable this MTLS communication.
It's wonderful.
You had other question, I think.
Yeah, I think this pretty much answers it, because I was thinking that Envoy and eBPF can't go together, but your later example says even that is possible.
It is, yeah. That's what I wanted to clarify as well. So it's not like you completely do away with Envoy. There are cases where you might still need Envoy or some other proxy. Like for example, even Linkerd works with Calico. I think Linkerd does not work with Cilium, but Calico uses Linkerd.
Okay.
So you can read more about them as well. Cool. Recently, at least last week, there was this eBPF conference. There are a lot of different talks throughout this conference. One of the very interesting talks was I think creating these high-level proxies. Give me 1 second. I don't remember the talk of the top of my head, but it was on day 2. Schedule, yeah. So one of the talks on day 2 was regarding building a load balancer from scratch using eBPF. So you can also do load balancing. That is, Kubernetes does load balancing through IP tables. That is, using your service object, you actually create these IP table rules. You manage these IP table rules, which do a round robin kind of thing. That is, they ensure that any incoming packet will flow to the next application, next instance of that application, instead of the current instance of the application which gave out the response previously. So you can also use eBPF to do your load balancing itself. So you completely remove the need of having any IP tables within your cluster. So it eliminates, so you can use Cilium also as a replacement for your kube proxy, for example.
Wow, this is very, very exciting. Looking forward to learn more about it. Yeah.
Yeah, eBPF actually took me by surprise. I didn't know much about it. I've been doing a lot of research on it in the past month. So it's been awesome to learn more about it. But yeah, I look forward to talk about it probably in the next meetup, whenever that happens. But yeah, just wanted to give you an overview right now. I'll stop sharing now. If you're interested in talking about something, we can talk about it. Talk about something else as well. If there's any technology which caught your eye, which took you by surprise, or we can probably call it a day as well. All right, cool. I think that's pretty much it then. Thanks everyone for joining in. I hope you had a good learning session today. Thanks once again, Aditya and Vikram, for your wonderful talk. Really happy about it. I'll be posting, I'll be editing and posting the video probably sometime around next week. Once I get the video from Zoom on the Chennai Go YouTube channel. Thanks everyone.
Thank you so much.
Sure. I do have the repository. It's all open source. It's just something which I use for trainings. Give me 1 second. I can share the repository, the examples which I was using. It's all open source. So you can look through that as well. Right. Thanks, everyone. See you all the next time.
Thank you, Gaurav. Thank you. Thank you, Gaurav. Thank you all.
Bye-bye.